next operator is what? Backward difference operator, and is denoted by the notation del. This is the notation for backward difference operator. In last lecture, learn the forward difference operator, and that forward difference operator is denoted by the notation delta, and here is the second operator, backward difference operator, and this operator is denoted by the notation del. And what is the definition of del fx? So del fx is fx minus f of x minus h. That is the value at the same point of the function f minus value at the previous point. So what is the previous point of x? Is x minus h is the previous point. Okay, and so this is the definition of del fx. That is the definition of backward or ascending difference operator. So what is the definition of forward difference operator? That is delta. The delta fx is what? Fx plus h minus fx. That is the value for the next point minus value at the same point. And but the del fx is what? Is the value at the same point of the function f minus value at the previous point, or backward point. Okay, that is previous point. Previous point of x is what? X plus h. So here is the definition. What? Definition of backward or ascending difference operator, and this is what? The value at the point minus value at the previous point. So what is del f of x plus h by using definition? Is fx plus h minus fx. That is the value at the point minus value at the previous point. What is the del of f of x plus 2h? Is x plus 2, f of x plus 2h minus f of x plus h. So the value at the same point minus value at the previous point. If we use the notation instead of this fy, that is what is del y1? Is y1 minus y0. What is y1? Y1 means the value of the function y at the point, and what is y0? Is the value at the previous point. Okay, so what is del y4? Is y4 minus y3. So value at the point minus value at the previous point of the function. So this is the definition of del. It's called backward difference operator. So what is del square y2? Is del of del y2. So what is del y2? Is y2 minus y1. Value at point point x plus 2h. What is y2? Y2 means f of x plus 2h. What is y1? Is value at x plus h. Value of the function f at x plus h. So what is y0? What is the meaning of y1, y2? These are given in the previous lectures. That y0 means f of x0. Y1 means f of x0 plus h. That is the value at x0 plus h. And so here is del y2 is what? Del y2 is y2 minus y1. Value at the point f of x plus 2h minus value at the point f of x plus h. So then apply this or multiply by this del in bracket. What do we have? This del y2 minus del y1. That is the distributive law. And then del y2 is what? Y2 minus y1. Value at the point minus value at the previous point. Minus, write in bracket either. Write here bracket, or write directly that del y1. What is what del y1? Y1 minus y0. Because of this negative sign, what we have? Minus y1 plus y0. Actually del y1 is what? Y1 minus y0, but in bracket. So by taking the effect of this negative sign, we have minus y1 plus y0, and then add these middle two terms. We have this y2 minus 2y1 plus y0. So this is a del square. This is del square y2. So similarly, we can find del square. Next is what? Del square f of x plus h. What is del square f of x plus h? Is del of del f of x plus h. Del of del f of x plus h. And what is del f of x plus h? Is f of x plus h minus fx. The value at the point minus value at the previous point. So the previous point of x plus h is what? Is x. So how we can obtain the previous point? By subtracting h. So x plus h minus x is x. And how we can obtain this next point? By adding h. So what is next point of x plus h? Is x plus 2h. Then the point is x plus 3h. By adding h, we have the next point, and by subtracting h, we have the previous point. So this del f of x plus h is what? F of x plus h minus fx. Then apply del on both. So del f of x plus h minus del f. Then what is del f of x plus h? Value at x plus h minus value at the previous point. So what is the previous point? Fx. X is the previous point. Okay. Minus, write it either here bracket or take the effect of this bracket, this negative sign. So what is del fx? Is fx minus f of x minus h. This del fx means fx minus f of x minus h. Write here bracket and then write fx minus f of x minus h. Or the after the effect of this negative sign, what we have? This term negative and this minus f of x minus h become positive. And then adding these middle two terms. So what we have? F of x plus h is minus 2fx plus f of x minus h. So this is del square f of x plus h. In this way, we can also find del square f of x plus 2h, del square f of x plus 3h, or del square f of x. So actually, this is del square f of x plus h means y1. Y1 actually f of x naught plus h is y1, but the next is the shift operator, and the notation for shift operator is E, and is also called a forward shift operator, or only just say shift operator, or displacement, or a translation operator. This operator is called shift operator, or the displacement operator, or translation operator. And the notation is this capital E is the notation for this shift operator or forward shift operator. Now, what is the definition of E of fx? That is, what is the definition of this operator E? E of fx is f of x plus h. Is not difference operator. Why the previous two are called difference operator? Because there is difference, there is subtraction of two values. So that is the difference. Here is this operator is not difference operator, and that's why E fx is only just shift the point to next point. So E fx is what? F of x plus h, the value at the next point. So next point of x is what? X plus h. So what is E of x plus h? Is f of x plus 2h. E of f of x plus 3h is what? F of x plus 4h. And in this way, that is the find the value of the function at the next point. And general in the notation of y, E of yx is what? Yx plus 2h, x plus h. So what is E of y naught? Is y1. E of y1 is what? Is y2. In this way, E of y3 is y4. So what is E square fx? So E of E fx, by using the definition of composition of two functions, E square means E into E, and f into gx is what? F of gx. By using the definition of composition of two functions, we have this. And this E of fx is what? F of x plus h, the value at the next point, f of x plus h. And then E of f of x plus h is what? Is f of x plus 2h, the value at the next point. So the next point of x plus h is what? X plus 2h. So if we find E cube fx, so what is E square fx? Is f of x plus 2h. And then E cube, if we find E cube fx, then it is f of x plus 3h. And therefore E raised to n fx is what? F of x plus nh. So then the inverse shift operator or backward shift operator. This is called backward shift operator or inverse shift operator, or just say inverse operator, and is what? E raised to minus 1. And what is definition of e raised to minus 1? So definition of e raised to minus 1 is this: e raised to minus 1 fx is f of x minus h. That is, find the value of the function for previous point. So what is the previous point of x? Is x minus h. What is the previous point of x minus h? Is x minus 2h, then x minus 3h. Then what is e raised to minus 2 fx? Here is not 1, right here 2. So e raised to minus 2 fx is what? Is f of x minus 2h. That is, shift the point to the left 2 points. E raised to minus 2 means shift the point to left. That is the previous 2 points. Shift the point to left. E raised to minus 2 fx is what? F of x minus 2h. So in this way, e raised to minus n fx is what? F of x minus nh. That is, the shift the point to left n points. Then examples on these operators are the relations between delta, del, and e. That is the relation between forward difference operator, backward difference operator, and shift operator. So first relation is what? 2 delta is equal to e minus 1. E is equal to delta. So so EFX. So EFX is what? Delta fx plus this fx, and delta fx is what? F of x plus h minus fx. So minus f of x plus h and f of x cancel to each other, and we get value is equal to f of x plus h. That is EFX. Okay. So either prove by this method, this example, or show that EFX is equal to in bracket 1 plus delta fx. So find value of EFX, that is f of x plus h, and find the value of 1 plus delta fx. What is 1 plus delta fx? Here is 1 plus delta fx. Is delta fx plus fx. And what is this delta fx? Is f of x plus h minus fx. So minus fx and fx get cancelled to each other, and therefore we have f of x plus h, and that is the equation number 2. So this is equation number 1, and that 1 plus delta fx is equation number 2. And so from 1 and 2 we have e is equal to 1 plus delta, and as e is equal to 1 plus delta, therefore delta is e minus 1. Okay. So we can also prove this separately. We can prove this delta is equal to e minus 1 through delta fx is equal to in bracket e minus 1 fx. So find the value of both separately, that is find delta fx and e minus 1 fx, and name it as equation number 1 and 2, and observe equation 1 and RHS of equation 1 and 2, both are same, and therefore we have delta fx is equal to e minus 1 fx, that is delta is equal to e minus 1. So next example is show that e into del is equal to del into e is equal to delta. So in order to show this, show e delta fx is equal to del e fx is equal to delta fx. Find value of all these three separately. First, find e del fx. What is e del fx? Is e del of fx. E del of fx by using the definition of composition of two functions. What is the definition of composition of two functions? F into gx is f of gx. So e del fx, and what is del fx? Is fx value at the point minus value at the previous point, f of x minus h. And then multiply by this e in bracket, we have this. And what is e fx? Is f of x plus h. Shift the point to next point. And what is e of f of x minus h? Is fx. That is the value at the next point. And this is what? This is equation number 1. Don't write it is equal to delta fx. Separately find delta fx. So this is suppose equation number 1, that is f of x plus h minus fx. This is the value of e del fx. Then find the value of del e fx. What is del e fx? Is again by using definition of composition of two functions. Del e of fx. And what is e of fx? Is f of x plus h. The shift operator, definition of shift operator. E of fx is f of x plus h, value at the next point. And what is del f of x plus h? The value at the same point, f of x plus h, minus value at the previous point, minus fx. And suppose this is equation number 2. Then find del this delta fx. What is delta fx? Is f of x plus h minus fx. That is the equation number 3. And then write that e del fx is equal to del e fx is equal to delta fx, and that implies e del is equal to del e is equal to delta. Okay. So we have this. Next example, show that either this is the example, show that 1 plus delta into 1 minus del is equal to 1. And in order to show this that 1 plus delta 1 minus del fx is equal to fx, that is multiply both sides by fx. So in order to show this, we have to show this. Okay, so consider LHS 1 plus del 1 plus delta into 1 minus del fx. Again, f into gx is f of gx. So 1 plus delta 1 minus del fx, then multiply by fx. So 1 into fx is fx minus del fx, and then del fx is what? In bracket, because there is negative sign. So in bracket, del fx is what? Fx minus f of x minus s, the value at the point minus value at the previous point. So then this minus effect of this minus on bracket is what? Minus fx. This plus fx and minus fx get cancelled, and minus minus plus f of x minus h. 1 plus delta f of x minus h. Then this is equal to what? Here is the value of e is 1 plus delta, but don't write the values of this e as 1 plus delta as e. In another method, what we have? We multiply this f of x minus h in the bracket. So what we have? This is f of x minus h plus delta f of x minus h. And what is delta f of x minus h? Is fx, that is the value at the next point, minus f of x minus h. And then f of x minus h and minus f of x minus get cancelled to each other. We have the answer fx. So either by using this method or delete this step and multiply this f of x minus h to bracket, we also have the same, this fx, and that is 1 into fx, and these two are equal, and therefore these two are equivalent, that 1 plus delta 1 minus del is equal to 1 or is equivalent to 1. Okay, so if we have to prove this, that delta minus del is equivalent to delta into del, we prove delta minus del fx is equal to delta del fx. So how we can show this? Find this value of this quantity separately, that is the equation number 1, suppose, and value of this quantity, and that is the equation number 2. And observe 1 and 2 RHS both are RHS of both are same, and therefore we have this, and therefore we have delta minus del is equivalent to delta into del. The next example, prove this, del is equal to delta e raised to minus 1. So how we can show this? Find del fx and then find delta e inverse fx and show the value of both are same. So first find del fx. What is del fx? Here is not delta, here is right del. So del fx is what? Fx minus value at the same point minus value at the previous point. So this is what? Fx minus f of x minus s. Previous point is this, and this is the value of LHS. Suppose this is equation number 1, and then find delta e inverse fx. So what is it? Is delta e inverse fx. And what is e inverse fx? Is f of x minus h. And what is delta f of x minus h? Is fx minus f of x minus h. And so value of this del fx and delta e inverse fx both are same. Equation number 1 and equation number 2. From equation 1 and 2, we have this delta del fx is equal to delta e inverse fx, and therefore del is equal to delta e inverse. So these are the some exercise. For example, e is equal to 1 plus delta e raised to n is equal to 1 plus delta raised to n. We prove this result by using mathematical induction. That is, show this is the true for e is equal to 1. That is, first write the proof of e is equal to 1 plus delta. That is, the result is true for n is equal to 1, and then assume the result is true for n is equal to k or m, and prove the result is true for k plus 1 or m plus 1. Okay, so the proof is by mathematical induction. We prove also this e del is equal to del e is equal to delta. Then proof of this, similarly we prove del is equal to 1 minus e raised to minus 1. So how we can prove this? Prove del fx and value of del fx and value of 1 minus e inverse fx both are same. Similarly, how we can prove this? Prove del fx, find the value of del fx and find value of e raised to minus 1 del e inverse delta fx and show the both the values are same. Similarly, the proof of this, that is how we can show these two operators are same. We show the effect of these operators on fx are same.